today, 22nd April 2024 evening, on a very special and pertinent topic, Introduction to 5G Security and Networking Technology on Amazon Web Services by Mrs. Shirin Bhambhani. She is live from US for this session. I'm privileged and honored to welcome Mrs. Shirin Bhambhani, a distinguished senior solution architect at Amazon Web Services, AWS, with over 7 years of industry expertise spanning from network engineering to spearheading the design of comprehensive solutions for enterprise needs. Mrs. Shirin Bhambhani brings a wealth of knowledge and expertise to the table. Her specialization in cloud networking and security is backed by a robust educational background, including a master's degree in telecommunication engineering from the University of Maryland, College Park, Maryland, USA. Mrs. Shirin's contribution extends beyond her professional endeavor. She has shared her insight at numerous AWS events and has made notable contributions as a published author. Today, we have the privilege of hosting her session on 5G networks in the AWS public cloud. Join us as she shares insights of this cutting-edge technology and its integration within the AWS ecosystem. With this short introduction, I invite Mrs. Shirin Bhambhani for this session. We are eager to hear you, ma'am. Over to you. Please go ahead, ma'am.
So maybe before Shirin, you start, I just wanted to add what Madhukar said, that this is a group of faculty member and research scholars from 100 technical institutions, basically engineering colleges, which includes some IITs, NITs, triple ITs, and also some private and government colleges. So these are the institutes where Government of India has allotted to set up 5G lab. So 100 5G lab program you might have heard. So all the faculty members and scholars are from those institutes only. So with this background, I hand over to you, Shirin. Over to you.
Sure. Thank you so much, Shokshi and Madhukarji. This is a great platform and I'm very privileged to be here. I'm going to just start off by thanking everyone for, I know it's quite late in India, and I deeply appreciate the time everyone has taken out today to learn more about 5G networks on AWS. I'll start off with a quick introduction of what we'll be spending time over for the next 60 minutes, and then I'm going to dive into the content for today. So today's session is going to basically focus on how telcos are building scalable, secure 5G networks on the public cloud Amazon Web Services. For those of us who are not aware, Amazon Web Services is one of the most comprehensive and broadly adopted clouds, and it offers over 200 fully featured services. What I'll do is I'll start off with an introduction to Amazon Web Services, what the infrastructure looks like. Then we'll do a recap of 5G, particularly what the challenges that telcos face with 5G. And then in the second half of the session today, we'll be talking specifically about security at AWS and some deployment patterns and controls for the secure operation of 5G networks in the AWS cloud. So I just want to make sure that everybody can see my screen. I have the agenda slide on right now. So if, you can just, Madhukarji or Shukji, if you could just say yes, no, I can.
We can see, we can see. Yes, thank you.
Perfect, so thank you. So as you can see, I have prepared a short agenda for today. We have 60 minutes and there's a lot of content. So hopefully we'll be able to cover everything. And towards the end, you're going to have a question and answers round as well, if time is permitting. So moving on to basically a very short introduction of Amazon Web Services. Basically, Amazon Web Services is a platform, cloud platform, where millions of customers, including startups, enterprise customers, government agencies, they all use AWS to host their applications, to build their networks in order to lower their costs, in order to become more agile and just innovate a lot faster. AWS has unmatched experience, maturity, and reliability. With 17 years of experience, really. So with this, customers get 17 years of experience of delivering cloud services to host their variety of use cases, really. So why do customers choose the cloud? A very short brief into this is organizations around the world we see move towards a cloud-based infrastructure for 6 reasons basically: to increase IT agility, to make sure that they have unlimited scalability, to improve reliability, to lower costs, to have a faster pace of innovation, and to basically be more sustainable as well. So moving to the cloud really allows customers to innovate faster because now customers are able to focus their valuable IT resources on basically developing applications rather than doing the heavy lifting of managing infrastructure and data centers. And that is what we'll show how even telcos are able to take advantage of really. So what you see over here right now are the basic building blocks of AWS. When I say they're the basic building blocks of AWS, what I mean is these are the various, I would say you can think of them as containers, what customers are leveraging AWS with to host their applications. So they leverage AWS infrastructure, which is basically our regions and availability zones. I'm going to talk about that in just a minute. So AWS infrastructure basically to create their networks. Now, how do they create their networks? They create their own virtual private clouds or virtual private networks based on this infrastructure. And in those virtual private clouds or virtual private networks, they can host their applications on some computing platforms. They can be Kubernetes platforms, they can be standalone bare metal platforms, or just virtualizations of instances. And then having a single pane of glass to manage all of this, having a single pane of glass to deploy all of this. All of these become sort of like building blocks on top of which customers can then run their databases, host very complex applications, and have very specific security controls as well. So what we have over there are, think of them as the global infrastructure pieces of AWS. Starting from the leftmost, we have regions and availability zones. Region is basically the physical location really, where a group of cluster of AWS data centers are hosted. And in the next slide, I'm going to show a pictorial representation of this. And I'm explaining all of this to really build upon the foundation of how a network is hosted on AWS. Availability zones are basically what make up a region. They're a group of data centers which are geographically a little bit closer, and that comprises of a region. Local zones are the AWS infrastructure piece that we have running in some metros really to bring the infrastructure closer to our end customers in order to host really low latency applications. And we'll see this, how telcos are able to leverage local zones in order to host certain parts of their 5G network. I'm not going to go into too much deeper points of presence. These are basically edge locations that a lot of CloudFront distribution can use in order to host their media applications. So, things like Netflix, things like Prime TV, all of these can host these their media applications on these edge locations, which are present across all of these points of presence. Let's do this. I'm going to go towards my next slide, and over there, we'll dive a lot deeper into all of these different services as well. So over here, what we see is what the region design looks like. So as I was explaining, a region is a physical location in the world where we have multiple availability zones. We have a lot of regions across the entire world, and that is where customers can host their specific 5G network functions. And we'll see what that looks like as well. And when I say they host their 5G networks on that, what I mean is they create their own networks using the virtual private cloud or virtual private network services, and then host them on top of compute services like Kubernetes services, or just bare compute EC2 services, which is our Elastic Cloud Compute service. Now, what we have is availability zones, and this is pretty critical to our sort of foundation of having failover capability in the cloud, which is basically we want customers to utilize multiple availability zones in order to have a more resilient and a more tolerant, highly available environment. So if customers are deploying their workloads in a region, they can utilize multiple availability zones in the region to make sure that you are really taking advantage of the resiliency of the infrastructure. So what we have over here is the continuum of AWS services, really. And this is what a lot of customers and a lot of specifically telco customers are able to take advantage of in order to host their applications, really. So I'm going to start from the left and go towards the right. So for applications that are running in AWS, customers basically experience the full scale elasticity service offerings, really, of what AWS has to offer. And this would be specifically, you would see in the region. Now, what is interesting is the evolution of a whole set of applications, really, that is driving requirements for performance at edge. And that is what we see specifically for telcos. Specifically, if you think about, the RAN component or the user plane component, we see a lot of telco customers wanting to have their user plane component a little bit closer towards the edge, a little bit closer to their end consumer base than running in the regions. And that is where we see customers taking advantage of something called AWS Outpost, which is sort of like customers' on-premises facility, which provides the telcos with a fully managed service, really, that extends the AWS infrastructure and services to the on-prem facility. We have something called AWS Local Zones, which, as I explained previously, is basically bringing the infrastructure deployment to metro cities. And that's where basically no region would exist. So then what telcos are able to do is they're able to utilize compute, storage, databases really very close to their large population consumer base. We have something called AWS Wavelength, which is basically the infrastructure offering, which is really optimized for mobile edge computing applications, really. It is deployed with the telcos. It is deployed within the telco data centers. So the application traffic from basically 5G devices can reach the application servers without ever leaving their network. Now, as you move further towards the right, you see more non-data center locations, really. On the bottom, you see a snowball edge and a snow cone. These are actual hardware devices that customers can use in order to host their compute applications in like really disconnected edge locations. Think of like ships or think of like factory floors, really. So with snow cone and snowball, they're able to have a wide set of edge locations. They're able to deploy their networks on a wide set of locations like hospitals and outdoor environments as well. Then we have on the top right corner, you would see AWS IoT and robotics services, which are very ideal for factory and smart home use cases. So I wanted to give a very brief background on, some of the services that we see pretty much a lot in use with telcos and why do they use that. Now let's shift gears towards a little bit more about, what the 5G challenges are, what opportunities we see over there, and some of the reference architectures with the 5G network evolution on AWS as well. So we have all heard a lot of things about 5G, and this audience over here is really well versed with what the 5G technology is and how it is changing the ecosystem and the way network telecommunication technologies are looked upon. So in that sense, I think there are three fundamental things that make 5G very different from, the other networks, really, from the other network technologies. The first one being around latency. With the critical applications that we see customers run on 5G, latency becomes a very critical factor for them. 5G really promises significant reduction in latency, and that is one area which is highly important for these mission critical applications, as we like to call them. The other one for all the customers that we see is basically of speed. So 5G promises speed up to 10 gigabits, which is roughly, a lot more than what is the max speed that we're getting today right now. And with this, we can think of use cases like media workloads, virtual reality applications, really. So with high speed, there is a vast area of use cases that are getting opened up with 5G. And with all of this, there's a significant increase, not just with speed, but also in terms of bandwidth, right? Just think of the number of devices, both on the consumer side, in our homes, on the industry side, that have like significantly increased over the years, right? Everybody has a mobile phone now. The number of devices in any given area has just become significantly higher. There are so many IoT devices as well in the mix now. And 5G really solves the problem of, of bandwidth, as it offers like millions of devices per square kilometer, really. So when you tie all of these together, there's a very big use case opportunity, different use cases can be solved with 5G. So what we have over here are some of the challenges that we see communication service providers or telecommunication service providers face. And what we'll see with one of the reference architectures is how it solves for these challenges that we see. So what we see over here, firstly, if you see, is service providers have around the world invested quite heavily into 5G technologies to solve for like complex problems. But they face some common challenges. For example, many of the communication providers, they offer, what services they offer are running on legacy equipment. They have merged and formed partnerships with other communication providers as well. So now they have to make use of legacy infrastructures, really. And in order to make use of these legacy infrastructures to work together, they sometimes have to modernize them as well. So we are talking about virtualizing not just the 5G core network, but extending it all the way towards the RAN, towards the radio access network. And then with the diverse ecosystem of applications and partners that they are running into with these networks, there is an exponential increase in the radio and transport networks as well, that are then requiring sort of edge cloud, edge computing technologies. We see there's a lot of complexity coming in with this diverse ecosystem of applications. And now service providers need to basically orchestrate all of these complexities away from these services, away from the 5G network. So how are they able to do that? How can they do that, really? And finally, after they have built all of these great complex networks, right? How will they monetize from this? Basically, how do they do that beyond just their regular traditional consumers, but for their mobile consumers as well? So how do you additionally monetize these 5G networks in each of the different application use cases that they're offering? So we just looked at the challenges that the telcos and service providers face with 5G technologies, but there are also some challenges that the end consumers and the industries that are using these technologies are facing as well. The first one being security, right? Now there is a significant number of devices that are getting connected. So how do consumers keep these devices secure? That's one of the challenges that we definitely want to think about when designing these networks. Then there is a challenge in certain industries around connectivity. Thinking of like mining industries, manufacturing industries, very remote locations, really. How do we maximize productivity by having connectivity at these remote locations? So that's one of the areas that we are seeing customers talk about as well. And what do we talk about when they're creating these networks, right? There's a lot of legacy equipment. So there's a lot of overhead happening in order to maintain these legacy equipments. How do we take that away so that undifferentiated heavy lifting is taken away from the service providers? So let's now move on to the 5G network evolution on AWS and see how we can solve some of these problems, really. So what we have over here is basically a typical model of the 5G network infrastructure, really, which is composed of, as you can see, a 4G, 5G radio side, a front haul, mid haul, back haul network, a core network side, and a telecom IT data centers. Now, the telcos definitely can use, cloud services to create a scalable, flexible 5G network infrastructure. And they can do that by implementing sort of the virtual NOC, maybe in the AWS region, and host the OSS, BSS applications and the majority of control plane network functions in the region as well. We'll see what it looks like in AWS in just the next few slides as well. You can implement the local central office or the distributed data center fleet on AWS local zones or AWS outposts and host some of the user plane functions, such as UPF or the RAN central unit or the multi-access edge computing network functions really close to the end customers. With that, you're able to do like voice traffic with very low latency to the end customers, really. So what we have here is basically a vertical view of a 5G network on AWS. And this is based on what we call at AWS the well-architected framework. That framework really helps customer to build a secure, high-performing, resilient, efficient applications really for a variety of different workloads. It's built around 6 pillars: operation excellence, cost optimization, sustainability, performance efficiency, reliability, and security. And with the infrastructure, with the cloud infrastructure, customers are able to build applications to make sure that that they are really abiding by these different 6 principles. So what we see over here in this vertical view, you can virtually implement, the mobile switching office or the central data center in the AWS region that is going to host the OSS, BSS, and majority of the control plane core function. And that can run on, a variety of compute offerings. Then you can implement the local central office or the distributed data center with a fleet of AWS outposts and local zones, hosting majorly the user plane functions, MEC 5G functions, RAN CU, the UPF, all of that can be hosted across the different MEC 5G, across the different fleet of outposts and local zones. And that is when it gets connected to the radio access network that you see over there. From the outpost, from the local zones, there is a connectivity happening, which we call as the last mile connectivity to the radio access network, to the radio unit or the cell site, which is where the subscribers are going to connect to. So one of the main advantages of this sort of a deployment becomes the single pane of glass of unified orchestration, not only for the services deployed in the region, but also just extending it towards, your edge, really, towards your local zones, towards your outposts, towards these edge services. Telcos still have just the single pane of glass through AWS Management Console for orchestration, for monitoring, for logging, for security, and so on, really. So this diagram is going to allow us to visualize what all it looks like inside the cloud. So with a cloud native 5G core deployment, if you see over here, we have the core network functions and the OSS BSS running in the region, like in the previous diagram. And you see they're running in the virtual private cloud, which we were talking about. That is sort of your own private network where you can run all of these compute applications, databases. And these VPCs are then connected through a hybrid connectivity model to the AWS edge services like Outpost, where we have the user plane functions running. Now, this connectivity between the region and the outpost or the local zones runs over something what we call as service link, which is basically leveraging an encrypted set of VPNs to communicate with the home region. So the service link is going to be the connection between your outpost and your chosen AWS region. And in your outpost, you can run, the user plane functions, and in the region, you can run the control plane functions. So that gives us the control and user plane separation, one of the principles with 5G network. With the architecture that we have up there, this also gives us the service-based architecture that 5G has. We can aim to sort of follow a more modern software architecture approach and then build on a microservices application, really. So this becomes like a container-based microservice application that can be powered by Kubernetes, that can be powered by Docker, that can be powered by a whole fleet of different computing flavors that are available in the industry now. You can use very specific service mesh technologies to discover the resources which are sitting, in this distributed environment for various different purposes. And that's one of the benefits of such a 5G architecture, that a lot of this can be reused for blueprints and best practices.
Hello.
Sorry.
Hello.
Yeah.
Yeah,
Ma'am, can you tell about CUPS?
Yeah. So if you see over here, this is on the screen, right? So CUPS is basically the control and user plane separation that we're talking about. And that happens because your control plane network functions, your OSS, BSS network functions, they're all running in the region, really. And the user plane network functions are running in your edge computing. So when I say edge computing, they're running closer to the end user. So when they run closer to the end user, they're able to basically leverage local zones and outposts or any edge computing facilities in order to do any voice calls, in order to do any user plane functionality. And that's what you see over here. If you see over here in the edge 1 and edge 2, we have the UPF and the VCU running in one edge, which would be connected to a set of RAN sites, really. So this is going to get connected to a set of RAN sites, which would be serving the traffic for only that particular user base, consumer base. They would not need to go all the way to the region for any control plane functionality. So that's the separation that we are talking about over here.
Okay, ma'am, can you use pointer to just follow up easily?
Sure, yeah. Okay, so yeah, so let me explain that again then. If you see over here, we have the UPF, VCU.
Yeah, understood that, ma'am. Just in future also, just use
definitely
the pointer.
Definitely, I'll do that. I think with this slide, I thought the animation would help, but I'll do that. I'll have the pointer over there.
Maybe you can choose the laser pointer, right click and choose a laser pointer. So that will kind of, yeah, pointer option, and then you can have laser pointer.
Awesome. Yeah. Is this helpful? Yes.
Yeah, yeah. Now it's. Ask.
Sorry.
Can I ask one question?
Yeah. I thought you were saying something, but I couldn't hear you. Go ahead.
Okay. Amazon has all these services, like any enterprise can straight away go for 5G hosted on Amazon Web Services. So my question is whether these are available in our country, India. Suppose some of the institutes want to simply go for AWS kind of 5G deployment. So is it possible in India as of now, or is there any plan AWS would launch this in India?
So there are regions in India. There are AWS regions in India. There's one in Mumbai, and let me really quickly check if there are. So there are regions in India that I know of, and even the other services that you see over there. All of these different services. Is the pointer working? Yeah. All of these different services, a lot of them are available natively in these regions, so they would be available in India as well. The local zones and outposts, give me 1 second. I'm just going to check that, how that is available in India, because these are available in very specific metros. Yes, so AWS Outpost is also, as of 2020, it was available in India as well. So these can be ordered by the customer. They will roll into the same data centers that the customers have, and then they can take advantage of creating the different network functions on top of Outpost natively.
Okay.
So yes, this becomes available in these Outpost services as well.
So I have heard that in USA, a lot of enterprise level fellows are using AWS for campus kind of a network, and they are using the spectrum which is meant for CBRS for enterprise customers. So what about like in India? So we don't have a separate spectrum for enterprise as of now, the way USA uses CBRS for enterprise. So what's your thought like?
So I think I'll have to I'll have to check that a little bit, Ashokji. I haven't worked with a lot of the campus use cases. I know that they do utilize a lot of the same technologies, like they all utilize Outposts running in these campus facilities in order to serve their networks. But how they're utilizing the spectrum band, I'll have to check that, and I can definitely send you details on that if that's of interest to the group. Yeah.
Right. Thank you. Please go ahead.
Okay, so I see the pointer over there. Okay.
So, madam, like I have one question.
Yeah.
Is it audible? See, normally AWS like cloud services, we can go for any other cloud services as well. So AWS so this you're showing like the AWS has already developed the 5G setup. Is like that, or I'm confusing?
So let me take a step back and explain this. So this is an architecture pattern that telco service providers can use to create their 5G networks. So what happens with the different cloud providers is they provide the basic infrastructure and services that can be used by these network service providers, telecommunication service providers, to build on top of. What is the benefit of that? Basically, with this, they don't need to manage the underlying hardware or the underlying compute or the infrastructure running in data centers. What they will have to do is basically coordinate with vendors, or if they have their own software to run the UPF and the VCU, just deploy it on the already existing infrastructure that AWS is providing.
So they need not to like go for everything like from the scratch and then deploy there and then right.
Precisely, yes. And that's the core fundamental, excuse me, benefit of the cloud, right? It is taking away the, what we call that undifferentiated heavy lifting. So you take that away from your telecommunication service provider, give them the infrastructure, they can run the network functions on top of it. Then.
Do we need like you were telling the right? So suppose I am in Jharkhand, Ranchi. So some use case I want to develop based on this one. So like again, you need to check like is it the services are provided at this location or not, or I cannot correlate.
So let's understand that. Let's say that you are a web developer sitting in Jharkhand, right? And you want to create your web application. And for that web application, you will basically create it on some server, right? That server can be something that the compute is provided by the cloud. In this case, that will be provided by something called, that you see over here. Where's my pointer again? Yeah, that you see over here. It can run on something called EC2 or EKS. These are compute offerings. When I say they're compute offerings, they are basically server alternatives. So these are already like the hardware, the infrastructure, everything for this is already provided. What you need to do really is deploy them, basically just create and instantiate them, put it in your VPC, which will be running in your Mumbai region, that will be the closest one to Jharkhand. That's why I'd say Mumbai region. And then with that, what happens is all you need to do is deploy or write your application on top of these instances. And then it can serve traffic for your end customers. That was a very simple, use case. Similarly, for something like this, if you're able to order your Outpost to a data center sitting in Jharkhand, there are some site requirements in order to get an Outpost rack. This is basically a set of servers, really, which is just like AWS infrastructure that is delivered to your doorstep. You can run the same application, the same UPF and CUs on top of the Outpost rack that can be delivered, or that can be used in your data center, in your location. So this becomes like a hardware that can be delivered to you, as long as there are some site requirements that need to be fulfilled for Outpost.
Fine. Thank you.
Yeah, hopefully I was able to answer or explain a little bit how this would look like in any environment. And since I have taken a moment here, I'm going to just drop these information over here as well in the chat, so that the team participants can take a look at it later on whenever they want. Okay. There are a couple of very good resources on how you can deploy outposts in India, and how you can also have these different architectures, what are the best practices to follow, what are the site requirements that you require for having these edge locations, and I can share that. I'm not able to share on chat over here. It says chat meetings, channel meetings is only available for team members, but I can send that out towards the end of the presentation. Okay, awesome. So now we're going to talk a little bit about the security design principles and controls in this particular in a 5G network, really, from what we have seen from our customer bases. Before I jump into the design principles for a 5G network and I have some reference architectures for that as well that I'm going to showcase in a bit. I want to explain a little bit about the security of the cloud and the security in the cloud. And that is something that we called as the shared responsibility model. And that ties back to, really what the customer or what the telecommunication provider in this case are going to be utilizing for their networks, and what they're not going to be managing for their networks. So in this case, what you see over here is basically a demarcation with the security of the cloud and security in the cloud. So security of the cloud is basically AWS is going to be responsible for protecting all the infrastructure really that is running these services. So the outposts, the local zones, the regions, all of that, the security of all the hardware, of the facilities, of the networking components, all of that is the responsibility of the cloud provider of AWS in this case. Security in the cloud, that is basically the customer responsibility. So when I say it's the customer responsibility, they would be determining what or who should be able to access their computing technologies or their storage units, so that there is no unnecessary access happening. Unnecessary attack vectors are not able to log into your EC2 instances or your compute functionalities in order to access any of the applications hosted there. So what that means for us really, when we are hosting the OSS BSS applications in the region, the VPC underlying hardware, the region facilities, all of the security of that becomes the responsibility of the cloud, becomes the responsibility of AWS. But the security of what are the IPs that can access my application, or what are the how the traffic flow is supposed to look like, that becomes the responsibility of the communication service provider really. Any of the security configuration, any of the access management tasks, all of that becomes the responsibility of the customer. So that's just the shared responsibility model that we want communication providers to be aware of when they are looking to deploy networks in the cloud. Now we'll move a little bit towards the general design principles and controls for from AWS for a 5G network. And this is basically a layered approach with defining policies and control objectives really that will help manage risks for any communication provider. You would see a lot of very specific things over there in terms of governance, in terms of workload operations, in terms of threat detection model, in terms of data protection. And these have been curated and created by making sure that they're aligned with 3GP practices, making sure they're aligned with what the customers are asking for and how they're really designing and implementing their models. So there is a white paper for this that I will be sure to share along as well, which really dives deep into all of these different principles. So if we see over there, the first one on the left-hand side is security governance, really. And security governance over there would basically entail regarding the roles and responsibility boundaries. Telcos should consider these things when they are hosting their network functions in cloud. who's going to access what, which of their operators is going to access which particular network function. And this is going to make sure that they are able to limit the permission to the absolute minimum, which is going to be in line with the least principal access privileges. Have workload separation. Different network functions should be sitting in their different AWS accounts. Think of things like, having a different account for, let's say, NEF, and having a different account for NRF. In that case, you are doing to get separation on an account level, and then you're going to get isolation through an account level. What I mean by account is basically an AWS account becomes an isolated environment for a specific workload. That is where you create all of these different services, all of these different applications. An account would basically make sure that there are boundaries for any workload, any environment. So have workload separation really. Have central management. Communication providers should consider establishing a central function which will act as a management plane and as an enablement function as well for their business development research units. This could be in the form of a central team or a distributed team or like a center of excellence, but there needs to be central management for best governance. There should be data classification. For example, control plane data, user plane data, call data records. All of these are some of the data classifications that service providers should use to determine if the storage that they're using or the service that they're using is going to meet the security and compliance requirements for those specific data types. Guardrails. Create guardrails. Make sure that there is a baseline that is being created in order to evaluate any deviations of any expected behavior really. So have guardrails, create guardrails to implement controls really in your environment. So we move on to identity and access management. So over there, you'd see there are basically two types of identities which must be managed when approaching like the operation of any secure network workload. And with that, we also talk about secure workload operations. There is threat modeling, which provides a systematic approach to finding and addressing security issues early on in any design processes. You want to identify and validate control objectives. So when you want to identify and validate control objectives based on service providers' service requirements, based on the compliance requirements with respect to the country that they're governing in or with respect to the protocols they are following, make sure that you're threat modeling, make sure you're validating any objectives and controls that are going to apply to the network workload. Enable logging. Enable logging is one of the most important and critical things to consider for service providers, because there's so much data that is flowing through all of these 5G networks that you want to make sure that you're logging everything in order to have data for auditing, for any machine learning, for making sure if you need any data for troubleshooting, you have that available. So enable logging is a critical one as well. Some more general principles that we have in terms of how you want to do data protection, in terms of how you want to do infrastructure protection. Infrastructure protection comes in 3 flavors, really. That's the one that I want to focus about a little bit more. You want to protect the network. You want to protect the compute as well. Now, when you want to protect the network, you would be protecting it at 2 fronts, at the edge and within the boundaries as well. What we mean by within the boundaries becomes really think of a specific network function like control plane, right? When you are having control plane, the network functions in control plane, like OSS, VSS network functions in control plane, you want to make sure that any data that is being transferred to it is getting encrypted. So any transport layer data traffic that is happening between your outposts and the regions, you would want to encrypt that to make sure that encryption at rest best practices and encryption in transit best practices are being followed. And by default, at the transport layer between outposts and AWS regions, the encryption is happening over there. protect the network at the edge. So what does that mean for us? So think of a network function like network exposure function, right? Which is going to be used to expose any network information to the external consumers. That can be protected by some firewalls, really. So those could be firewalls that are protecting the infrastructure, these network functions. And the service providers don't have to create the firewall. They don't have to get heavy equipment for the firewall. They can use some native firewall services and technologies that we provide in order to protect these functions without doing any provisioning or maintaining of the infrastructure. The last one is protect the compute, and protect the compute is important in terms of because that's where your network functions are going to run. So with that, there are some key things that we want consumers, customer service providers to be aware of. Use pre-hardened compute. Hardened images would basically reduce the exposure to any unintended access. They are created by hardening operating systems, by minimizing any unintended access with these images. Now, when I say images, hardened images are basically so any compute offering that you use within a cloud that has to be created from somewhere, right? So like, let's say you want to use a Linux-based server. So you would be using something called the Linux-based image in order to create that particular server. So this image becomes sort of the blueprint of that particular server, and that needs to be, it should be pre-hardened, basically. You want to have patch management. You want your workloads to have newly patched images in order to take place, or in order to ensure that you're not using any outdated images, really. And that is going to make sure that your patching is taken care of. Use very specific instance types. And these instance types should not have overly permissive access, really. Access should be strictly limited to a very specific set of authorized and administered APIs. And that is basically how you want to access all of your compute. You don't want access to be allowed from everywhere. You want very specific authenticated access to be there. So over here, what we have is just a list of different services that AWS offers in order to really do all of the design principles that we spoke about earlier. We have a lot of identity and access management services. We have a lot of detection and response services, network and app protection services. These are some of the services that we see our customers using on a daily basis in order to make sure that their network boundaries are protected. We have a lot of data protection services for data encryption in transit, for data encryption at rest. Not just that, even for any certificate management, even for any password management, all of these different data protection services are there to make sure that you're compliant with any specific requirements. So now what we want to talk about, I have a set of three basically reference architectures, three examples really, and how the security boundary is getting shifted a little bit in each of these different reference architectures. So the first one that we have over here is basically the deployment of the control plane and the user plane. Both are in the region in this case. And we are just basically connecting it with the service providers, service providers data center through something called a direct connect connection. This direct connect connection is basically it's dedicated connectivity for the customer, really. So they can connect their data center directly to the region using this direct connect. Keep in mind, there is no outpost or local zone over here. This is just standalone physical connectivity path that is between their data centers and the AWS region. So we're going to check what are some of the security controls in this architecture, really. So we'll start with the direct connect connection, right? So over here, what you see is the AWS direct connect connection will be providing, since it's dedicated connectivity between the service provider and the AWS region, it is not going over the internet. So that is taken care of. This also supports MACsec. to encrypt data between the on-premises, in this case, the communication service providers facilities, and AWS. So this will make sure that your data is getting encrypted with an IEEE standard, really, that provides integrity, authenticity, and confidentiality. This can be used, this can also be encrypted using IPsec tunnel or TLS encryption, which is as indicated in 3GPP standards to secure any network domain. Now, once the traffic gets over here, right, you have something called VPC route tables. Now, this is going to determine where the traffic needs to go. So over here, we can get the functionality of making sure that the routing is happening exactly where you want it to go to. So that's where traffic is going to get directed, and this gives an additional security benefit to make sure that your traffic is not going in any, any unintended direction. Over here, you're also able to utilize something called security groups to control the traffic that is going in and out of your compute resources. This is going to basically act as a filter. Security groups and network access control list act as a filter on an instance and subnet level. Then we have something called the hardware that are going to be used for all of these compute resources, where you're running your control plane and user plane network functions in this architecture is a very specific AWS Nitro-based hardware-based instances, which are deployed using all security benefits of pre-hardened images, of patch management. So these are already pre-hardened network images, really. Then if you see over here, we have, in number 5, we have data storage. And this is persistent data at rest, and that can be, encrypted by a data key. And these are basically block storage volumes that customers can use to encrypt any data. They can bring their own keys to encrypt their data, or they can use AWS services for key management. It's up to them. Now, you can also do this if you want to access any services that are not inside your own VPC, but they're outside a VPC, but you want the traffic to still be private, not go over the internet. You can utilize something called endpoints, transit gateway, to make sure that it does not flow over to the internet. So this is going to make sure that your traffic stays within the backbone, does not go over the internet. So over here, we have a lot of different services as well, which customers can use in order to protect their network boundaries. KMS is going to be the key management service that they can use in order to encrypt their storage, the block storage, or in order to encrypt any other storage services that they use as well. Certificate manager is going to be utilized. They can utilize that for any certificates that are needed for making sure any domains are being connected to over HTTPS and not HTTP, or if you want to have any load balancers encrypted or utilize any specific certificate, they can use the certificate manager for that. S3 bucket. S3 bucket is our simple storage service, which is basically a very elastic storage service that customers can use. This they can basically keep putting in objects, putting in files, in order to have unlimited storage, really. And you can, have security features on top of that. You can lock the bucket. You can make sure only very specific access people can check out a bucket. Whatever security features you want to put in terms of object download, object viewing, and object upload, all of that can be done with S3 buckets. Similarly, EKS, ECR EKS is our Kubernetes service. This can be utilized to make sure that any of your, I think I went one step ahead. Sorry about that. Yeah, so this can be used to make sure that your Kubernetes workloads are running on pre-hardened images, like the Nitro-based instances that we were talking about. So this can be used for your network functions to run in a Kubernetes environment. ECR is the container image repository. This can be used to scan images for security vulnerabilities. Images are also encrypted using KMS in this case. So this can be used by customers to store their container images. We have AWS CloudTrail, which helps in governance and supports basically auditing of any actions that are taken by any user or any administrator on any AWS services. So they get recorded over here as events. CloudWatch is used to collect and track metrics, logs, events, any such telemetry data can be utilized with, can be collected by CloudWatch, and then can then be used to trigger any any prevention, any security vulnerability that it detects. So let's say that you are seeing access from a particular IP happening a lot, and you want to get alerted. This can alert you on that. And even logs from intrusion detection systems and intrusion prevention systems for firewall applications can be forwarded to CloudWatch and then can be used to alert on. Similarly, we have AWS WAF, AWS CloudFormation and Config. WAF is basically going to be the web application firewall, which is basically the firewall that sits at the edge, network at edge. So you're able to protect your network functions and applications from any layer 3 and layer 4 attacks using WAF. With CloudFormation, you can deploy your entire application and network functions in minutes, really. These are basically sort of automation tools that you can use in order to deploy your entire infrastructure and application system in a couple of in a very short span of time. So reducing the time for deployment from months and days to a matter of hours, because these are redeployable blueprints and templates that customers use. So this one was a reference architecture where we have the control plane and the user plane in the region, right? We also have a reference architecture where the control plane is in the region, but your user plane is on outposts. And over here, then what happens is you are able to get a lot of the same functionality on outpost because it's like an extension of the AWS infrastructure, really. So if you see over here, we have a lot of the same functionalities over here: VPC route table, of security groups, of the Nitro-based worker instances, of the EBS volumes, of the Elastic Block Storage volumes. So a lot of the same components are coming into picture over here also, but these would be running in the service provider's local facilities, really. So they're just getting extended from the region to the local, to the service provider's facilities. So there is one thing to keep in mind over here, though. If you see over here, we have over here with Outpost, what they can do is they can also have their own local network get connected to Outpost. So that's why you see a lot of these VRF routers connected to these Outpost servers. They can be service providers' own routers, virtual routers of forwarding devices they can use to segregate the traffic, and they can connect it to their outpost racks, to the outpost servers that are being deployed in their facilities over something called the local network, really. And with this, they're able to segregate the traffic even further out. Lastly, in this third example, we will take RAN into consideration. So if you see over here, we have the 5G RAN deployed over here at a customer's premises, really. In example one, the 5G core was running within the region, and this is just an extension where the RAN components and where the RAN components are running on the customer premises. You see over here that the CU is running in the local zone. This can be running in the local zone or in the outpost. It depends on the customers. But the CUDU over here is basically running on customer premises, really, then. So a lot of the same security features would be here as well, just as described in the previous examples. The security-related services and the best practices would be applied over here. Focusing a little bit on the RAN deployment, and I know we are at time over here, so I'm just very quickly going to cover this. Due to latency requirements of the RAN network functions, the CU needs to be placed within a couple of milliseconds from end users, and that's where local zones and outposts are the ideal locations to host all of these different CU functions. So if you see over here, the connectivity is over the direct connect connection, which again is very highly secure because it's completely dedicated to the customer and is private. In the sense, it's not going over the internet. So this provides that extra layer of security as well. And at the RAN level, the security features of the customer's premises really come into picture over here because this is completely going to be managed by the customer. So I think that was a very quick overview and introduction on how these architectures look like on AWS. These are some of the content we have in terms of white papers, in terms of the same architectures that we discussed today. They will just dive a lot deeper into it if you're interested. If you like, I can send these along as well to Ashokji and Madhukarji for the audience's consumption. And yeah, that was basically what I had to say for everyone over here. I hope this was a little bit useful.
Yeah, thank you. Thank you. Thank you for sharing these QR codes. That would really be useful for all the participants. I think we are recording, so it will be with us. So one can take screenshot or from the recording, they can use that. And in case you can share these slides, we'll be able to share to participants. Yeah.
Yeah, I'll definitely do that. All of these are white papers, which I will be sharing as well with you, Ashokji, and you can share them across with the participants as well. There are a lot of different very specific architecture videos and deployment step videos as well, workshops as well that the participants can use. So I'll share all that as well.
Thank you. Thank you. May I request all the participants to kindly open your mic and video so that we can have a small discussion, or you may ask a question.
Madam, I have one question.
Yeah.
See, like you had shown the 3 architecture, right? So in those architecture, what I'm finding, the hardwares are also there, like RF sections, like antennas are also there, base station. So actually, what part is done by the AWS, right? So generally, I understand like the cloud is we can keep for storage or like for processing, and we can keep it there. But how these architectures and in those architecture hardwares are also you are indicating. So
yeah, let me actually go back here and share.
Can you make it a little bit clear?
Yes, I'm going to just explain that. Do you see my screen? You should see one of the architectures over there.
Yeah, you can see it.
Awesome. So the hardware of basically the hardware and the infrastructure is managed, and the patching of the services of the hardware. Sorry, the patching, the management of the security of the hardware of the OS gets managed by the cloud provider, that is AWS. But anything on top of that, in terms of let's say that you're running a user plane function on EKS service, the Elastic Kubernetes service. So you're running it in a containerized fashion, right? Now, in order to protect it from any unauthorized access, to make sure that, like, let's a simple example, you don't want port 80 connectivity from a certain IP. That would be on the customer though. That particular segregation of what are going to be the networking and security configurations in terms of access, in terms of IP management, in terms of routing, all of that becomes the customer's responsibility. The underlying infrastructure, that becomes the responsibility of the cloud. That actually goes back to the, let me show the model again, the shared responsibility model. So over here, AWS becomes responsible for protecting the infrastructure that runs. Customer is responsible depending on what services you're selecting. If they're managed services, it's a different thing. But for basic compute services, anything in terms of networking controls, anything in terms of access controls, firewall management, think of it like if you put a firewall in front of your servers, right? The firewall configuration is still the customer's responsibility and to protect the server. So that is still over here, but it comes in the form of security groups and in the form of network access control lists for the customers to manage. So that would become that would be on the hardware distinction. Now on
my question was like which part will be done by the AWS, right? And so this architecture may be as a reference,
Sanjit,
like where we want to do the processing. So with those part we can like do it
Sanjit,
from the AWS.
Sanjit, can I add to what Shirin said? Like AWS is ready with all the network function of 5G, which includes all the core network function, AMF, SMF, UDM, everything. And also there is a possibility that the radio part. So suppose you want to build a campus network and you want to take services of AWS. So basically from the nearest data center of AWS that may be present there, a lease line or MPLS line would be required, so that from your campus to the Amazon cloud services, you have a pipe or the link. And then in respect to the radio, the chances are that AWS will supply those pre-configured radios. You only need to install onto your premises, and all other network function can be running on the AWS cloud itself. If you want, UPF can be part of your network. If you have a small server or a small data center in your campus, the UPF and also the control plane part of the base stations can run on your hardware. Otherwise, the boxes can be supplied even by AWS. So it's a plug and play. Once you decide that you want to build a campus network, it will be all plug and play mostly. But the AWS will give you all the access so that you can configure your network yourself. You can manage your network yourself. You can scale your network yourself by paying whatever charges they have. Shirin, whether I replied correctly or
yes, I just want to add a little bit. The UPF, the SMF, all of the network functions, right? The network functions they're not out of the box with AWS. They come from the partners, they come from the vendors themselves, but they can run on the AWS services. So what I mean by that is, let me explain that. Let's say that you want to run a UPF, right? Where will you run the UPF? The where is something that we can solve for. We do have a service called AWS Private 5G, really, that basically would give, that is basically sort of like an out-of-the-box managed service that makes it easier for customers to deploy their own private mobile network. And that comes with a lot of the things that, are really out of the box. That is basically, you just deploy and manage your own private mobile network. That we have a service called AWS Private 5G. But what I'm talking about in this reference architecture is basically how you can utilize the AWS infrastructure to create a 5G network, or sorry, not you, how the service provider will utilize the AWS infrastructure to create a private 5G, to create a 5G network. And in terms of what Ashokji said, yes, you can use the lease lines to connect to your radio units to all of these particular AWS infrastructure. So that can be done.
So yeah, obviously, like in that case, latencies issues. So how significant the latency issues will be there? Like, because several things, and like you are giving the security also, and at different layers. So will the latency will be also affected or not?
And that is why we have the option of the edge infrastructure. Because with the edge infrastructure, specifically with Outposts, what you can do is have it as close to your radio units that you want. Because these are not, they get ordered, like you or I could order these Outpost servers, infrastructure servers by default and have them at my own data center. So wherever you want to host closest to your user, you're able to do that with the edge services. So that's the power of getting it towards the edge. And that is specifically designed to make sure that latency requirements get met.
Yeah. So here also I can add, Sujit ji, like the complete user plane part of the traffic is within your campus. That means radio is in your campus. The user plane function of the 5G is in your campus. And as Shirin said, you can have the edge deployment where your application is also running into your premises itself. If your application is, say, AR/VR service, so AR/VR service is running on the edge within your campus. If it is gaming, it is running on the edge. So basically, latency would improve, not deteriorate per se.
Thank you.
Ma'am,
Continuing. Yeah, continue, ma'am.
Ma'am, I would like to know what's the maximum limit on the amount of cloud resources you can use, because from the PPT I've understood that AWS include storage, databases, networking resources, and so on. Thereby, I'm hoping there will be some limit in it, or
So let me take this. So cloud by default has a lot of elasticity. When I say elasticity, customers don't really need to worry about what the limits would be in terms of infrastructure that is being provided. But every account per se, so if you see all of these things, they run in a particular, for a user, they would have an account where they're running all of these resources. Every account has what we call as service limits or service quotas. And that gets adjusted really based on what your utilization is. So they can be scaled up to the limit that, like all of these EC2 instances or Kubernetes clusters, all of these resources can be created to a limit that you want, as much as they're within your account quotas. But the quotas can be increased and decreased as well. Cloud by default is very scalable because the customers don't need to manage the infrastructure. That gets managed internally by the cloud provider, by AWS. So infrastructure management, provisioning of infrastructure, making sure that the infrastructure is scalable, all that gets managed by AWS. Customers don't worry about that.
And the limits vary depending on the specific service and the region, or it's constant AWS region.
So there are a few services. Like there are some core services that we have, which basically would be the networking services, which would be the virtual private cloud service, which would be a compute service, the Elastic Cloud Compute service. These are all core services, and their limits are fairly consistent. Some services which are not available in all regions, they might have different limits. But if there is a particular service you're interested in, our public documentation would very clearly provide if it's not available in a particular region and what the limit is for a particular region. But that would depend on the service a little bit.
Okay. Thank you, ma'am.
Yes.
Ma'am, this I'm continuing the previous questions related. The services is mostly based on the cost, right? And there, as you said, that elasticity. So depends upon our research application, we can increase or decrease, right? Another thing is that, as Ashok sir has also added, wherever you have shown some physical component kind of thing, these physical components can be interchanged with the software components. Is it, or the different?
Okay, so the physical components that, like, let's say the RAN units, right? Those are the physical components that we can be looking at. The RAN units those are completely hardware, or those are the cell sites that are provided by the telecommunication service providers. That's not what AWS is providing. But let's say you have a very major database that the customer or the service provider is hosting themselves, that they can utilize AWS service, something like we have an entire fleet of database services that they can utilize or create their own database on AWS. So then they don't have to manage the underlying hardware and server for the database service. But yes,
Thank
it is based on usage, and depending on cost. If customers see or subscribers see that there are a lot of databases that are running and there are ideal, there's nothing happening, that would contribute to the cost, but they can have alerting based on that and then ensure that their cost utilization is in terms of what they're expecting for the service use to be.
Yes, ma'am. Means that is some of the legacy systems which we cannot replace with the software. That will be there in infrastructure part, physical part. So wherever we can make it as a like a edge and other thing. So
Yeah.
sometimes in this thing it is possible to replace with the hardware and software. Depends the way we have configuring the structure. So the limits will be there for replacement and the elasticity component. Is it?
So there are so this goes into a different discussion, but there are a lot of different methods of even replacing, really. Sometimes it's a complete change, sometimes it's not a complete change, sometimes it's what you have in the legacy environment, you want to put it directly into the cloud. That is also possible. Sometimes you don't want that at all, you want to completely modernize. That is also possible. So that depends. Yeah.
My question is mainly if a researcher want to start on security aspects kind of thing, what kind of feasible study they can look into this parameter so that they can carry out the security problems on based on the this integrated part of the cloud or AWS and 5G technology. That was the my intention of the question.
Got it. Yeah. Thank you for the background.
So, madam, one last question from my side. Like, see, AWS is providing the hardware as well as software, both cloud services together, right? So, see, as you know, like we 100 institutions, we got the setup from the DOT, that 5G setups. So suppose if we only ask for the software, AWS, your reference architecture or the software part or cloud part, right? So we need not to develop anything there, and then with our hardware, so how much it is feasible and in terms of cost or for an institution or a small group, how do you see it?
So the
first thing is that software, only software part, only cloud part is possible or not with your architecture, so that we can it can be connected with any other hardware that has been provided to us also, right?
So yeah, so that is go ahead, sorry, complete your thought.
Right, so that is the first thing. Another thing is that is it feasible? How will it be very costly for a small group or of people to work on that and to purchase those services, or what is that like? Can you a little bit elaborate and so that it will be useful?
Sure. So the labs and the hardware that has already been provided, so the AWS infrastructure or the AWS hardware, that is what the services run on. That is what our AWS services run on. So they will not be, so the AWS cloud would not be running on the labs per se that you have, but you can connect those labs to an AWS environment. So that's what we call as a hybrid connectivity model. So let's say you have a lab, right? And that lab has a network in it. Now you can connect that particular network to your AWS cloud environment. And that you can do through VPN tunnels, through the direct connect service as well. Mm-hmm. So over here, I'm going to just go, I don't think I have a reference architecture for that over here, but let's see if we can be a little bit creative. Think of this as your own lab. Think of this as the lab. Don't think of this as the local zone. Think of this as a lab and think of this as the network, right? You can connect your network through IPsec tunnels or through VPN or through direct connect to all of these different functions in the AWS cloud, all of these different services in the AWS cloud. So if you want to say you want to utilize monitoring, right? If you want to utilize monitoring for your on-premises or for your for the logs that are being generated by your lab, As long as you're able to send the logs to the CloudWatch service in AWS, you will be able to see the logs over there. That's one example, really. So depending on what service you're connecting to, the services are not going to run in your lab per se. The hybrid connectivity model is basically to connect to the services running in the cloud only.
Fine.
Does that answer the question? And now the cost piece, right? The cost piece would depend on what you're using in the region only, and what is the data you're sending from your labs to the region. In the sense, if you're using, let's say, an S3 bucket to store all the data coming in from your labs, you can send all the data to the S3 bucket through the IPsec tunnel, and you will get charged in terms of whatever the data storage costs are, data processing costs are for the S3 bucket and the IPsec tunnel costs.
Right. Thank you. Thanks so much.
Ma'am, continuing with the same question. So is something, some hands-on session is available on your website, so that first we can go through about these, and then we look forward for to buy or to work on these?
Yeah, definitely. We have a lot of open workshops. I can send those to you. When I can send like very specific workshops in terms of how to deploy an AWS network. I think that gives a lot of, if once you start deploying an AWS network, you understand really what I'm talking about in terms of hosting on AWS, in terms of creating compute on AWS. So yes, we have, the website is workshops.aws. I can send that. I can send those links to Ashokji as well when I'm sending this presentation out. But there are labs, yes.
And any certification program is also going along with this, like there is available with the AWS?
We do have AWS certificates. There are cloud practitioner certificates. There are solution architect certificates. I'm not sure of the training programs for the certificates, but there are cloud practitioner is the basic certificate that you can take in order to, and then there is the solution architect associate. Then there's a professional. There are different tiers, but there are a lot of certificates out there that you can you can study for in order to really dive deep into the cloud. And they're good certificates. I've done quite a few of them. They're very, very nice.
Okay, thank you.
Yeah. Any other questions? Any thoughts?
We already took almost a 30 minutes more than what we requested for, and it's like it may be your office time also now.
Yeah.
So
that's okay.
Yeah. So thank you so much for this wonderful session. Since we have recorded it, so many of the participants, because of the evening, might not have joined, so they can go through the recording and perhaps get benefited. So we are at the closing point. So may I request Madhukar for offering a formal vote of thanks. I think Subha ma'am was also, I saw ma'am in the, ma'am, if you like to say something, or shall we proceed? Yeah, thank you, ma'am.
Yeah. No, it was a really knowledgeable session for me also. I was not aware about so many things AWS is doing in the field of 5G, the security, and you are very rightly pointed out that how our labs, our institutes can be benefited with this type of services and systems. I'm sure Ms. Shirin Bhambhani is going to help us in giving the links, the related material, as well as connecting them with the right forums to all our participants, to our listeners. Thank you so much for that.
Yeah, actually, I wanted to just point out, there are a lot of AWS summits that happen in India, specifically for AWS Summit Mumbai, that would potentially, that actually have very specific targeted sessions on telcos as well. If you're interested, Ashokji, for the audience here, I'll share those details as well.
Thank you. Thank you. So thank you, ma'am. With this, may I request Madhukar to offer formal vote of thanks to Shirin ma'am.
Yes. A wonderful, captivating, and engaging session on very contemporary topic by Ms. Shirin Bhambhani. On behalf of Faculty Development Program team and all participants, we express our sincere thanks and deep gratitude to Ms. Shirin Bhambhani for her excellent presentation on the topic of Introduction to 5G Security and Networking Technology on Amazon-based web services. Ma'am, your presentation was very informative, marked by its depth and relevant to the contemporary subject matter. Your expertise and passion were evident throughout the presentation and offered invaluable understanding of the topic. Your presentation was rich in content, offered diverse perspectives, and delivered key insights. At the same time, your contribution as a distinguished speaker has greatly enriched our faculty development program. We also extend special appreciation to all participants whose active involvement made the session interactive and dynamic. Your contribution added depth to the discussion, enriching the overall learning experience. Once again, our sincere thanks to Ms. Shirin Bhambhani and all participants, and Subha ma'am also, for making this session a resounding success. Thanks to all. All regards. Jai Hind.
Thank you.
Thank you, everyone.
Thank
I'm
you.
gonna
Thank you. Thank you very much.
Thank you.
Thank you. I'll
Right.
drop off now.
madam.
Thank you.
The session was
Thank you.
wonderful.
Thank you.
Thank you. Thank you.
Thank you so much.
Thank you, Shirin. Thank you, Shirin.